Have a good day. Today we are going to discuss about operating system process. Okay. So in this session what we are going to discuss the main objective of the process and what is the process, how the process represent in the memory and how the process controlled by the operating system. This is process control block and various states of the process and process scheduling, and finally we are going to conclude the process. Okay. Then what the main objective of the process is to understand the process between the process and the program, the differences and the various life cycle of the process and the representation of the process in the OS. So these to understand all these items, this is the main objective of the this session. Okay, what is process? Usually the process it can be defined as a program in execution is a process. Okay, one program it can be a several process. Usually, the program is a passive entity, that is only the executable file. But the process is an active entity, that is in the execution. Okay, this is the definition for the process. Then how it is represented in the memory. Usually it's stored in the memory from the lower memory to the higher memory. So various elements that is used to represent the process in the memory. Okay, what are the elements? Usually the text section, program counter, stack, data section and heap. These are the elements which are used to represent any process in the memory. Okay, so what is the meaning for each of these items? Let's give a look at this program, C program. Here, usually hash include studio.h. So this is like a library, normal library. Then after this, we are defining the variables like int x, int y, that is equal to 5, 15, like that we are representing the some variables. These global variables usually stored in the data section. Then there is a main function. In this main function, there is some arguments. These arguments which are available in the stack section. Then the dynamic memory allocation, this is available in the heap memory. So this is how the entire program, C program, which is stored in the text section. So these are the representation of any process in the memory. Then how the process controlled by a operating system. So usually to control the process, the OS use process control block. The other name is task control block. So it have various information like process state, process number, program counter, registers, memory units and list of open files. So these are the elements of a process control block which is in the operating system. Okay, what is available in each items? For example, process state, whether process in the new state, running state, waiting state. So the upcoming session, upcoming video, upcoming slides, we will discuss about the process states. Okay, then program counter, usually it have the next executable instruction, and CPU registers which is used to store all the related information, the process related information. Then CPU scheduling information which is usually the scheduling priority and queue information. This information available. Then accounting information, usually this is the resources like CPU used and the clock and time limit. So all this information stored in accounting information. Then IO status information, then in IO devices allocated to the particular process, this information stored in process control block. Then various states of the process. Okay, what are the states? Like new state, running state, waiting state, ready state and terminated states. Okay, each of the states is represented in the following diagram. So see, just give a look at this diagram. Here, once the process is created, this is in the new state. Then once it is ready for the execution, then it will come to the ready state. Once it acquired the CPU, then it will be in the running state. In case there is any interrupt arise, then from running state to ready state, the process it will switch over. In case if it is waiting for some event to occur or some input output operation, then it will go to the waiting states. Then once the fulfill the requirements, then again it will go to the ready state. Once it's complete all its process, okay, the task, particular task, then it will go to the terminate states. So these are the various states of the process. Okay, then process scheduling. In this process scheduling, usually the main objective is to utilize the CPU maximum. This is the main objective of the CPU scheduling. So what are the elements involved? Usually the process scheduler. What it does, usually it picks the available process for the execution purpose. In this process, there are many queues available. The mainly the two queues are, one is a ready queue and another one is wait queue. So here you can give it the look. This is the first one is a ready queue and the second one is wait queue. Usually it's represented as a linked list in the memory. Okay, so it have the elements. What is the first element? What is the last element? So each one is represented process control block or task control block. So give a look at this presentation of process scheduling. How any process done the scheduling. For example, there are list of process. This is available in the ready queue and it's waiting for the CPU to get execute some task. For example, one process it will reach the CPU, it will perform some task. So when it's executing, if there are any task, it requires some input output operations. So in the time it will from the CPU, it will go to the input output request. Once arise, then it will be in the input output wait queue. For example, time, then another one is time slice expire. That means consider the round robin algorithm. When we talk about the round robin algorithm, so we will discuss about this in more detail. So time slice expire. When it's a scheduling algorithm used, usually they are using some time slice. Within the particular time, the process should execute its process. In case it needs some more time, one time point of finish means then it will go again to the wait state, but it again once it will reach the ready queue. Then for example, some process create the child process. So until complete the child process or terminate the child process, it will wait in the child termination wait queue. Then once the child complete or terminate its task, then it will go to the parent process, again it will go to the ready queue. Then there is some waiting for some interrupts. Some interrupt occur means then it will go to the interrupt wait queue, then again it will go to the ready queue. So in this way, any process it move between the different queues. Then in the conclusion, so we understand various queue system, what is the process, how it can be used for the scheduling, how to maximize the CPU utilization. So these are the things we are talking about process in this session, because to make the efficient multitasking and resource management, the process is more important. Understanding the process is more important. Thank you. So this is the reference. So I'm taking this material from the operating system concept. This is written by Abraham Silverskatch and this is issued by Yola University. So thank you so much.